Hello students, I am Dr. R. Krishnakumari, Assistant Professor, Department of Mathematics, SRM Institute of Science and Technology, Kattangulattur. Today we are going to see certain topics in probability and one-dimensional random variable. Now let us see the outline of this module. Initially we are going to see certain probability concepts followed by sums based on Bayes theorem, and then we are going to see about random variable. Probability concepts. Deterministic experiment is an experiment whose outcome or result can be predicted with certainty. Although all possible outcomes of an experiment may be known in advance, outcome of a particular performance of the experiment cannot be predicted due to certain unknown causes. Such an experiment is called a random experiment. The set of all possible outcomes which are assumed equally likely is said to be the sample space, and it is denoted by capital S. A subset of S consisting of all possible outcomes is said to be an event. Now let us see the axiomatic definition of probability. Let S be the sample space and A be an event associated with a random experiment. Then the probability of the event A, P of A, is defined as a real number satisfying the following axioms. 0 less than or equal to P of A less than or equal to 1. P of S is equal to 1. If A and B are mutually exclusive events, then P of A union B is equal to P of A plus P of B. And if A1, A2, A3 up to AN are mutually exclusive events, then their union is equal to their sum. Now let us see four important theorems based on the probability concepts. Probability of an impossible event is always 0. If A bar is the complementary event of A, then P of A bar is equal to 1 minus P of A, which is obviously less than or equal to 1. If A and B are any two events, then P of A union B is equal to P of A plus P of B minus P of A intersection B, which is obviously less than or equal to the sum of P of A and P of B. So this theorem is said to be the addition theorem. If B is a subset of A, then obviously P of B is less than or equal to P of A. Independent events. A set of events is said to be independent if the occurrence of any one of them does not depend on the occurrence or non-occurrence of others. If two events A and B are independent, the product theorem takes the form A intersection B, which is going to be equal to the product of A and B. Conversely, if P of A intersection B is the product of the probability of P of A and B, then the events are said to be independent. So this product theorem can also be extended to any number of independent events in this form. Conditional probability. The conditional probability of an event B, assuming that the event A has happened, is denoted by P of B by A. P of B by A is nothing but it is equal to P of A intersection B divided by P of A, provided P of A is non-zero. Product theorem of probability. By rewriting the definition of conditional probability, we get P of A intersection B is equal to P of A by B. And the product theorem can also be extended to three events A, B and C, such as P of A intersection B intersection C is equal to P of A, P of B by A, P of C divided by A intersection B. These are some important points that should be noted. So if A is a subset of B, then P of B by A is equal to 1, since A intersection B is equal to A. If B is a subset of A, then P of B by A is greater than or equal to P of B, since A intersection B is equal to B, and P of B by P of A is greater than or equal to P of B. If A and B are mutually exclusive events, then P of B by A is equal to 0, since P of A intersection B is equal to 0. If P of A is greater than P of B, then P of A by B will be greater than P of B by A. And if A1 is a subset of A2, then P of A1 by B will be less than or equal to P of A2 by B. So these are some important points that should be noted while solving the sums. Now let us see the first sum. A lot consists of 10 good articles, 4 with minor defects and 2 with major defects. 2 articles are chosen from the lot at random without replacement. So find the probability that both are good, both have major defects, at least one is good, at most one is good, exactly one is good, and neither has major defects and neither is good. So they have given 7 subdivisions that should be solved. So for to find the probability that both are good, so totally they have given 10 good articles with 2 major defects and with 4 minor defects. So totally there are 6 articles with defects. So 10 plus 6 is going to be 16. So to find the probability that both are good, so it is going to be 10C2 divided by 16C2, so which is going to be 3 by 8. Now to check whether both have major defects, it is going to be 2C2 divided by 16C2, so it is going to be equal to 1 by 120. So next one is the probability that we have to find that at least one is good. So at least one is good, it is nothing but that minimum should be one should be good. So it is going to be 10C1 6C1 plus 10C2 divided by 16C2. So this is going to be equal to 7 by 8. And the next one they have given that at most one is good. At most is nothing but maximum only one should be good. So it can be neither it can be good or maximum it should be one good. So it is going to be 10C0 plus 10C0 into 6C2 plus 10C1 6C1 divided by 16C2, which gives the answer when solved as 5 by 8. The next one they have given that exactly 1 is good. So for exactly 1 is good, it is going to be 10C1 6C1 divided by 16C2, which is going to be the value as 1 by 2. So in all the cases, the denominator is going to be 16C2. Since they have choosing only 2 articles at the lot at random without replacement, and totally there are 10 good articles, 4 articles with minor defects and 2 with major defects, so totally there are 16 articles. Now the sixth one, the question is that neither has a major defects. So neither has major defects, it will be giving us 16 minus 2, therefore it is going to be 14C2 divided by 16C2, so it is going to be 91 by 120. And neither is good is going to be 6C2 divided by 16C2, so which is going to be equal to 1 by 8. Now let us move to the next sum. A box contains 4 bad and 6 good tubes. 2 are drawn out from the box at a time. One of them is tested and found to be good. So what is the probability that the other one is also good? So let A be a good tube drawn and let B be another good tube drawn. So the probability that both the tubes drawn are good is going to be the probability of A intersection B, so which is going to be equal to 6C2 divided by 10C2. So here 6 indicates the 6 good tubes and 10 indicates the 4 plus 6, that is the bad plus good, so totally 10 tubes. So the answer is going to be 1 by 3. Then by conditional probability, P of B by A is going to be equal to P of A intersection B divided by P of A. So which is nothing but 1 by 3 divided by 6 by 10. So the answer is going to be 5 by 9. If A, B and C are any 3 events such that P of A is equal to P of B is equal to P of C is equal to 1 by 4, P of A intersection B is equal to P of B intersection C is equal to 0 and P of C intersection A is equal to 1 by 8, find the probability that at least one of the events A, B and C occurs. So since P of A intersection B is equal to P of B intersection C is equal to 0 and P of A intersection B intersection C will also be equal to 0. Then P of A union B union C is going to be equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. So by applying the values here, we will be getting the answer as 5 by 8. Now let us see the statement of Bayes' theorem. If B1, B2, B3 up to Bn be a set of exhaustive and mutually exclusive events associated with a random experiment and A is another event associated with Bi, then P of Bi by A is equal to P of Bi into P of A by Bi divided by summation of I equal to 1 to n P of Bi into P of A divided by Bi. So this is going to be the statement of Bayes' theorem. Now let us see some sums based on Bayes' theorem. The first bag contains 3 white balls, 2 red balls and 4 black balls. Second bag contains 2 white, 3 red and 5 black balls, and the third bag contains 3 white, 4 red and 2 black balls. One bag is chosen at random and from it 3 balls are drawn. Out of 3 balls, 2 balls are white and 1 is red. So what are the probabilities that they were taken from the first bag, second bag and the third bag? So here we are going to use the concept of Bayes' theorem. So let P, that is the selecting the bag, P equal to Pi is equal to 1 by 3, where I is equal to 1, 2 and 3 because they have given 3 bags. Then P of A by B1 is going to be 3C2, 2C1 divided by 9C3 because totally there are 9 balls, and out of that we have to choose only 3, that is 3 balls. Out of 3 balls, 2 should be white and 1 should be red. That's why in denominator we have mentioned it as 9C3. So it is going to be, the answer is going to be 6 divided by 84, and P of A divided by B2 is going to be 2C2 3C1 divided by 10C3, and P of A divided by B3 is going to be 3C2 4C1 divided by 9C3. So then P of A is going to be equal to summation of I equal to 1 to 3 P of Bi into P of A divided by Bi. So by multiplying that we will be getting the value as 0.0746. Then P of B1 divided by A is going to be equal to P of B1 into P of A divided by B1 divided by P of A, and if we apply the values here we will be getting the answer as 0.319, and similarly for P of B2 by A we will be getting the answer as 0.4285, and P of B3 divided by A we will be getting the answer as 0.638. Random variable. A random variable is a real valued function whose domain is the sample space of a random experiment taking values on the real line R. A discrete random variable is one which can take only finite or countable number of values with definite probabilities associated with each of them. So the probability mass function of a discrete random variable is that, let us consider x to be a discrete random variable, then the probability p of x is equal to xi is equal to p of xi, where I is equal to 1 to n and xi are some assumed values. So this probability mass function satisfies the following two conditions. P of Pi is greater than or equal to 0 for every I, that is Pi should be non-negative, and summation of Pi is equal to 1, that is the total probability is equal to 1. A continuous random variable is one which can assume every value between two specified values with a definite probability associated with each. A function f is said to be the probability density function of a continuous random variable x if it satisfies the following two conditions. F of x is greater than or equal to 0 and integral of f of x is always equal to 1. So cumulative distributive function for discrete case is that p of x less than or equal to x is equal to summation of p of xi, and for continuous variable it is going to be f of x is equal to p of x less than or equal to x is equal to integral from minus infinity to x f of x dx. The moment generating function is the expectation of a function of the random variable. So the mathematical expectation is nothing but the expected value of a random variable x is defined such that if x is a discrete random variable, then e of x is equal to summation of I equal to 1 to infinity xi p of xi, where p of x is the probability function of x. And if x is a continuous random variable, then e of x is equal to the integral from minus infinity to infinity xf f of x dx, where f of x is the probability density function of x. Now let us see certain properties of expectation. So if c is a constant, then e of c is equal to c, and if a and b are constants, then e of ax plus b is equal to a into e of x plus b, and if a and b are constants, then variance of ax plus b is equal to a square variance of x, and if a is a constant, then variance of ax is equal to a square variance of x, and variance of x is nothing but e of x square minus e of x the whole square. So these are some important properties that are used for solving the variance mean, and also that are useful for solving sums based on mathematical expectation. Now let us see certain sums based on it. So a random variable x has the following probability distribution. So we have to find k, evaluate p of x less than 2 and p of minus 2 less than x less than 2. And we should also find the CDF of x, and we should also find the mean of x. So since summation of p of x is equal to 1, so we are going to sum the values and it is going to be equal to 1. From this we can find the value of k, which is going to be equal to 1 by 15. So that is going to be the answer of part A. And they have given and they have asked us to find p of x which is less than 2. So p of x is less than 2 is nothing but p of x is equal to -2, -1, 0 or 1 in the given table. So by applying the values of it, we will be getting the answer as 1 by 2. And next they have asked us to find p of -2 less than x, which is less than -2, so less than 2. So for this it is going to be p of x is going to be equal to -1, 0 or 1. By applying the values for it, we will be getting the answer as 2 by 5. So now we are going to find the distribution of x, that is f of x. So f of x is defined as f of x is equal to p of x less than or equal to x. So when x is equal to -2, p of x is going to be equal to 1 by 10. Then f of x is going to be equal to p of x, which is less than or equal to -2. So therefore it is also going to be 1 by 10. Now when x is equal to -1, p of x is going to be equal to 1 by 15. Then f of x is going to be equal to p of x less than or equal to -2 plus p of x less than or equal to -1. So which is going to be equal to 1 by 10 plus 1 by 15. So which is going to be equal to 1 by 6. Similarly, when x is equal to 0, f of x is going to be equal to 1 by 10 plus 1 by 15 plus 2 by 10, which is going to be 11 by 13. And when x is equal to 1, f of x is going to be 1 by 2. And when x is equal to 2, similarly, f of x is going to be 4 by 5 by adding all the preceding p of x terms. And when x is equal to 3, f of x is going to be equal to 1. So this is the distribution function of x. Now the last one is that we have to find the mean of x. So mean of x is defined by e of x, which is nothing but the summation of x into p of x. So e of x is equal to -2 into 1 by 10 plus a -1 into 1 by 15 plus 0 into 1 by 5 plus 1 into 2 by 15 plus 2 into 3 by 10 plus 3 into 1 by 5. So which is nothing but equal to 16 by 15. So now let us see the next sum. If a random variable x has the probability distribution function f of x is equal to 1 by 2 x plus 1, where x is greater than -1 and less than 1, we have to find the mean and variance of x. So mean is nothing but mean is equal to e of x and variance is equal to e of x square minus e of x the whole square. So to find mean, that is mu1, which is equal to the integral of -1 to 1 x f of x dx, so which is going to be equal to 1 by 2 integral of -1 to 1 x plus 1 dx. So if we integrate it in the limits -1 to 1, we will be getting the answer as 1 by 3. Now in order to find variance, we need to find the value of mu2. So mu2 is nothing but integral of -1 to 1 x square f of x dx, so which is going to be equal to 1 by 2 integral of -1 to 1 x cube plus x square dx. So if we integrate this in the limits -1 to 1, we will be getting the answer as 1 by 3. So thus by applying the value of mu2 minus mu1 the whole square, we will be getting the variance as 2 by 9. So in the next sum, if x has the probability density function f of x is equal to k e power minus 3x, where x is greater than 0 and 0 otherwise, we have to find the value of k. P of x, which is greater than or equal to 0.5 and less than or equal to 1, and we have to find the mean of x. So since the integral of minus infinity to infinity f of x dx is equal to 1, so therefore in the place of x f of x, we are going to apply k into e to the power of minus 3x dx. So when we apply the limits with the lower limit 0 and the upper limit infinity, when we integrate it, we will be getting the answer as k is equal to 3. Now to find the probability of 0.5 less than or equal to x, which is less than or equal to 1, it is going to be equal to, we have to apply the lower limit as 0.5 and the upper limit of 1 f of x dx. So it is going to be equal to 3 lower limit 0.5 with upper limit 1 e to the power of minus 3x dx. So if we integrate this, we will be getting the value for this probability as e to the power of minus 1.5 minus e to the power of minus 3. Now we know that the mean is going to be e of x. So by applying the formula, we will be getting the value of a mean of x as 1 by 3. So this is going to be the answer for this sum. Let the random variable x as the probability distribution function f of x is equal to 1 by 2 e to the power of minus x by 2 x greater than or equal to 0 greater than 0. So we have to find the MGF, that is the moment generating function, mean and variance of x. So to find the moment generating function, it is nothing but if you find the mathematical expectation, it is enough. So moment generating function mx of t is equal to e of e power tx, so which is equal to integral of minus infinity to infinity e power tx f of x dx, so which is equal to 0 to infinity e power tx 1 by 2 e to the power of minus x by 2 dx. So when we integrate this with respect to x in the limits 0 to infinity, we will be getting the answer as 1 divided by 1 minus 2t. Now to find e of x, e of x is nothing but the differentiation of mx of t with respect to t. So it is going to give us the answer as a 2 when t is equal to 0, and e power x square is the if we differentiate it twice with respect to t when t is equal to 0, we will be getting the answer as 8. Therefore the variance is nothing but e power x square minus e power x the whole square. So 8 minus 4, so the answer is going to be 4. So now we have come to the end of the module. Thank you students. Let us connect again in another interesting session. Thank you.